problem is called first factorial. Have the function first factorial take a number parameter being passed and return the factorial of it. For example, if number is equal to 4, then your program should return 4321 equals 24. For the test case, the range will be between 1 to 18 and the input will always be an integer. So we are going to write let total equal to 1 for I equal to 1. I is going to be less than or equal to number, and then I plus plus. It will be equal sign, not minus. Then total will be total multiplied by I. And we have to return the total, return total. So it satisfies all the test cases. Now we are going to use recursion. If number is equal to 0, this is the base case. So it is going to return 1. Why 1? Because 0 factorial will always return 1. Else it is going to return number multiplied by, we are going to call this, but we are going to decrease it by 1. Now if I run the test case, it solves all the test cases. Now let's see how it works. The function factorial takes one parameter n or number which represent the number for which the factorial is to be calculated. Inside the function there is a base case. If n is equal to 0, the function returns 1 as the factorial of 0 is 1. If n is not equal to 0, then the function returns n multiplied by factorial n minus 1. This is where recursion occurs. It calls itself with the argument n minus 1, effectively reducing the problem size with each recursive call until it reaches the base case. When n becomes 0, the recursion stops and the results are bubbled back up, multiplying each n encountered during the recursive calls. The result of the factorial calculation is then returned. So let's see how it bubbles up. Now, when I give 5, the number 5, it consider this as the call stack. So when I give factorial 5, it then calls factorial 4, then it calls factorial 3, then it calls factorial 2, then it calls factorial 1. When each of them resolves, then the result goes back to the factorial 2. So let's see how factorial 1 uh, gives its result. When factorial 1 is called, it hits the base case where n is equal to 0. Because if I put n equal to 1, 1 minus 1 is equal to 0. Then it will go back to this function. If n is equal to 0, it is going to give me 1 back. This value is 1, return the caller, which is factorial 2. Now the value of 1, factorial 2 will return 2, then factorial 3 will return 6, then factorial 4 will return 24, and then factorial 5 will return 120. So this is how the recursion works in this case. Now let's submit this. Our solution has been accepted.